Okay, good morning, everyone. We are all welcome to today's training session. I believe that we have all been impacted in one way or the other, and we've learned a new way of doing our work. I want to request that if anyone has a question concerning yesterday, I want to start by allowing just two people who can raise up their hands if they have any question. We'll give like 2 minutes. If under 2 minutes, nobody raises their hands. Okay, I can see Chibuki raise hand. If we get one more, we'll move. Okay, that's it, please. Nobody else will please raise hand. We have 2 participants raising hands already. Thank you very much. Please, whatever question you are asking, please make it short and very concise, very straight to the point. We don't have much time today. We have to finish 12 on the dots. Thank you. And so, Salisu, can you let me ask them to unmute so that they can ask that question?
They can speak now. Please.
Good morning, everybody.
Good morning.
Good morning, everyone.
Good morning.
Yeah, okay, my question goes this way.
Introduce yourself, please, and ask the question. We are only taking Bruno and Owolabi. So the Sahid should please put the question on the Q&A section. Thank you.
My name is Eno Chibike. My question goes this way. About the cells that when you put in digits, the format itself, it shows in a big format. How do you resolve that problem? I've tried putting in single digits like 1, 2. Still, it shows in big format. I don't know. How do you go about that issue? I think that's my question.
I don't seem to get the question. Did Stanley get it?
Yes.
Okay. So you can please answer him. Thank you, Mr. Bruno.
The date format issue, I explained how to resolve it yesterday. There are 2 ways you can resolve it. The first way is you can save that page as an Excel file, which there's a button there you click to save. So when you save the page, you open it as an Excel file. There's a place that you change it from date to number. You close it, then you import that page back to the application. Alternatively, you can also close the application, open it again, then start filling in the form again. It will not show the date format. But if you don't want to start afresh, you can just save the page as an Excel. Then there's a place you change. Let me maybe during the course of the class, I will show you how to do that. But the second method is for you to close the application, reopen it, then start afresh.
I've tried the second method a number of times, but it isn't working. Maybe I'll try the first one you just said.
Okay.
Okay. Ismail Owolabi, please.
Hello, good morning.
Please unmute yourself. Okay.
Good morning. My name is Owolabi Ismail. Yeah, I just want to ask, is it possible there is a brief recap on yesterday's session for those of us that missed the session?
We cannot do a whole recap, but the recordings will be sent to the WhatsApp platform, just like last week one was sent yesterday. But we'll try and make sure that we get the recording earlier in the week than what it was. I'm sure Stanley will still go back a bit, but you cannot get the full going back on what we did yesterday. But I'm sure we'll do something. Thank you.
Okay, thank you, madam.
Okay. So Stanley, I think we can go ahead.
Good morning, everyone. Good morning, the NIQS president, and national executives, waxing chairperson, and the executives, the YQSF members participating in this webinar, and other participants, ladies and gentlemen, good morning to you all. Welcome to the fourth day of our training. So far, we looked at how to use EQS2 software for auto takeoff and BOQ for different types of projects. On the first day, we looked at how to use it for a simple building without columns and column bases in the substructure. This phase of the training, we are focusing on just substructure. On the second day, we moved to a project, duplex project that has a column basis in substructure. Then on the third day, we looked at how to use the software to take off for raft foundation project, the substructural aspect. Today, we'll be looking at how to use the software for other taking off items, because the auto takeoff category has other forms in it. The form we've been working on is the one that allows you to do takeoff for almost all the elements in a project. We've been working on just substructure, but that same form allows you to even take off for some superstructural elements. But there are some other items under that main category. If you are interested in just a particular element, for example, let's say you're interested in only beam, or you're interested in only columns, or you're interested in only column base, or you're interested in just concrete wall or some other items, there are other forms that you just click that will allow you to work on those items. But the third item on that category allows you to take off for a good number of items in a project. So today we'll be looking at the forms that allows you to take off for a particular item or a particular element in a project. I'm going to
okay, Stanley, before you start, can you just shed more light? Somebody said he just wants explanation. I think it's the person that has to lower his hand. I'm only taking two. He said he just want more explanation on how to import some data input for correction.
Okay, let me
just a brief
okay, we'll go through that before we continue for today's class. Let me share the screen. If you want to import data for correction, let's say on the project we did yesterday, we use that as an example. You click on this main category, auto takeoff and BOQ. Then this is the third item we've been working on, building takeoff. This allows you to do takeoff for more than one item of work in a project. While the other items on the list allows you to take off for a particular item. As you can see, we have beam here, we have bulk excavation, we have ceiling and floor, we have column bases. Meanwhile, under this category, building takeoff, we have beam inside it, we have columns inside it, we have column bases inside it, we have block wall, we have a lot of things inside this third category. So I will show you how to import back a saved data to make correction or adjustments to the values. The first step is to click on that building takeoff and BOQ. Then when it's open, assuming we want to make correction on the first page, which is site and trench details, you see import button at the top right corner of the screen of this particular page, import page. When you click import page, it's going to bring up this pop-up window. This window, you are going to look at the file path. The file path is what is the cursor the file path shows you the directory that project is actually saved into. And the file path that we used yesterday is the 3 project. So if the project you want to import is, for example, day 2 project or another project, then you need to navigate back to the main folder, which is this EQS2 project. When you click it, it shows you the other folders in it. Or you can just click desktop. Desktop is on the left side. When you click desktop, it brings out all the folders on your desktop. Then you click on EQS2 project. It shows you all the folders. So you open the, if you want to work on day 2 or day 3, let's say day 3, you just double click. It opens all the pages that you have saved. And we are currently on site and trench details. So we want to make correction on some data there. So you just double click on this page or on this Excel file. So when you double click it, it opens. So you see it has brought back the values that we imputed. So let's assume you want to adjust the site area. Let's say you want to change it to 1,500 square meters. You click on the cell, that particular cell, then you change the value to 1500. Let's assume we want to make any other adjustment. Let's say the laterite filling, for example, you want to change it to 1.2. You just change it to 1.2. Then let's say you want to change the excavation to 0.8, you change to 0.8. So after you are done making all the adjustments, you click save page again. And in saving it again, you have 2 options. You can save it as a new file, or you can replace the existing file that is there. If you want to save it as new file, you just type a new file name here. The option 2 is if you want to replace the existing file, you click on the site and trench details, which is the file that we want to replace. Then you click save. Then it will ask you, do you want to replace this? Yes or no. So if you click yes, it will replace the old one with the new one. Then to answer the second the first question about if the values is showing you in date format. If you don't want to close the entire page, sorry, the entire program and restart, you can open, you can save that page, that particular page. When you save it, then you go to the folder on your desktop. Let's say this file now. For example, if this file is okay, I said that if this, like the other person that asked if it's showing you in date format, you don't want to close the entire program, you can save that particular page. So when you save it, you open it as an Excel file. So when you open it, I'll show you how to change the content there from date to number. So when you open that file as an Excel file, you highlight on the entire column that is showing date. For example, if this is showing, let's say 12/02/2020. You see, now if you check this on the toolbar up here, you see it's showing dates. Yeah. So what you're going to do is you highlight on the entire column. Then you change this from date to number. So that's just how you're going to do. So when you change it from date to number, you save that page. Control S, you save the page. So when you save the page, you close the Excel file. So after you close the Excel file, then you import it back into the software. You import that page back into the software. It will not show you date again. I hope that answers your question. So, Mr. Bruno, try it and get back to us on your results or experience. Thank you. I hope that answers the two questions.
Yeah, I think so. So we can just moving straight to what we have for today.
Today we are looking at some other items under this main category. We are looking at other items under auto takeoff and BOQ category. Like I said earlier on that we've been working on the third item, which is building takeoff. Building takeoff allows you to do taking off for quite a number of items of work or elements of work in a project. But if you're interested in just a particular item of work, let's say you are only interested in beam or you're only interested in column bases, you just click on column base. If you're only interested in beam, you just click on beam. But if you take note, in this third item, which we've been working on, we have beam there, we have column base there, we have site and trench there, we have block wall, we have a lot of other things inside here. So today we are looking at other items that we have apart from this main item. So we'll start with I'll start with column base because someone asked on the second day of the training that if she has a project that has two types of reinforcement in the column base. They have, let's say they have Y16 at the let's say they have Y16 and Y20. Let's say Y20 at the bottom, Y16 at the top. So I'll show you how to do that using this form. Assuming you are doing a group project and they only gave you column bases alone to work on, you can use this column base form to do it. Or maybe you just want to quickly cross-check some quantities in just a particular item. So on this form, the first thing is to understand how it works. The form has input and output section. It also has a description box, which is also part of the input section. Then most of the forms has a similar interface. They have input section, output section, they have button, they have add. The add means calculate. They have add button, then they have remove. Remove is to remove a job or a particular work that you did. Then wherever you see this drop down is a form that shows you options that you can select from. And after you are done with the input section, then the results page is just below the input section. The input section has text boxes, or we also call it numeric boxes, because these boxes You cannot input alphabet there. It's only numbers, so they are called numeric boxes. Why the text box allows you to input both alphabet and number, so it accepts alphanumeric data. Why the input numeric boxes accept only numbers. Each of the input box or the numeric box has a title, either at the left side or at the top. So if you can read and understand the titles on the top or beside each of the numeric boxes, it will guide you and tell you the actual value that you're supposed to input in that particular numeric box. And each of the numeric box also has a unit of measurement. So you should take note of the unit of measurement that is either at the top or beside each of the numeric boxes. Like I said earlier on, most of the forms, they have similar interface. This is, we are currently on a column base. If you check beam and concrete in beam, you see they have similar interface. If you check ceiling and floor, you see they have similar interface. They have input, the button, and then the results down here. Then you now have two buttons below that allows you to export and import results. So back to the column base, we start with the description. So the first thing, before we input description, let's look at a sample drawing. So assuming we have this as a sample drawing, this column base has top and bottom reinforcement. So let's say this is BT2 that has top and bottom reinforcement. But before we do that, we check at the dimension. This is the length, and this is the breadth. So this also requires you to extract the data. This is a group B data, which you can just read that directly from the drawing. So the length is 2 meters. The breadth is 1.2 meters. Then the excavation depth is not shown here. So let's assume 1.5 meters excavation depth. Then the blinding is given as 50 mm blinding. Then the column base is given as 0.4 meters. Then here we are assuming that the bottom reinforcement is Y16. Then the top reinforcement is Y12. So now the number of column bases here is just 2 numbers. So we input this data now in the software. We start with a description. Description, you put base type 2 because we are starting with base type 2. Then here, as you can see, it says column base dimension, length. The length is 2 meters. Breadth is 1.2 meters. Number of work means number thereof, or number of occurrence of that particular item, which is base type 2 column base. And from what we have here, it's 2 numbers. So you put change this to 2. The next is the excavation depth. The excavation depth, we are using 1.5 meters. Blinding from the drawing is 0.05. You know, it's 50 mm in the drawing, but I say you should be cautious of the units of measurement beside each of the boxes. Here, the unit is in meters, so that's why we have to convert it back to meters. The next is the footing. The footing is supposed to, this it's an error. This should be meters. So the footing is 0.4 meters. Then the next is the bar arrangement. So you can select whether it's double or single. Single is bottom only, double is top and bottom. So here we have we are assuming that we want to have Y12 at the top and Y16 at the bottom for base type 2. So in that case, you choose bottom only. Bottom only also means single. So in this case, we are going to do it twice for the reinforcement. We'll take the first instance which we are doing now is for the Y16. That's the one at the bottom. So you are required to provide the bend of the reinforcement, the bend in one side. So let's say we are using 0.1 bend in one side. Then the concrete cover, let's check if it's given here. Okay, the concrete cover is not given, but we can use 25 mm. So when you convert 25 mm to meter, is 0.025. So the next is length bar diameter. You know, the column base has length and it has breadth. So this form even allows you to input different diameters. If, for example, the length side, if the length side has Y16, breadth side has Y20, the software allows you to input different diameters. But in this case, the length and breadth, they have the same diameter. So we are using Y16 as the length bar diameter and Y16 as the breadth bar diameter. Then the spacing is given here as 200 centers to center. So we change it to meters, that's 0.2. So the length side, the spacing you provided, the breadth side, the spacing you provided. So when you are done, you click add, which is calculate. So with that, we have the result in the form below. The description is for base type 2. The next is volume of column base excavation, 7.2 cubic meter. Then the next is leveling and compacting, 4.8 square meter. You see, the result page here has columns and row. Each of the columns or each of the cell has a title at the top, and the title has a unit of measurement. Here, you see leveling and compacting, the unit is there. Anti-termite, the unit is there, which is in square meters. Earthwork support, blinding, column base, concrete, formwork to edges of column base. Then the reinforcement also, because the software allows you to input a different diameter of reinforcement for length side and breadth side of the column base. So even in the result, it is also separated. All the length reinforcement, the reinforcement in the length side of the column base is given separately. So you see, it gives you the total length of reinforcement in the length side in meters, in kg, in tons. If you scroll further, you can scroll when using this horizontal scroll bar at the bottom. If you go further, you see the breadth side. The reinforcement on the breadth side of the column base is 29 meters. Then the reinforcement on the breadth side in kg is 45.866 kg in ton is this. Then now we now have total. So yeah, it sums up the reinforcement in the breadth side and on the length side, and it gives you the total. So the total reinforcement in meter is this, total in kg is this, total in tons is this. So in a project that if the length side has different type of reinforcement as the breadth side, you can use this form, but you just need to write out the results from here. So yeah, I said we are doing double reinforcement, top and bottom. So we have done the top. So we can even change the description by specifying that we are using a Y16 at the top. So let's say Y16 top. So now I'm changing the description. So I'm going to click add again. So here we now have two results. So I'm going to remove the first one I did. And to remove it, I'm going to click on the row. So you see when I click on the row, it selects the entire row. And when you click on the row, it returns back all the data, all the values that yielded these results which we have here. You see when I click on this, the description here is base type 2. If I click on the second row, you see the description is returning what we used to get all the results here. So I'm going to delete this first row because I made a mistake in the description. So to delete a row is you click on the row, then you click remove. When you click remove, that row goes off. So in this case now, we have done for the top. So if you are doing for the bottom now, we just change the description to Y12 bottom. So when you're doing for the bottom, you don't need to do excavation again because we've already done excavation. So the excavation depth, you put 0. You don't need blinding again. The blinding, you put 0. You don't need footing again. The footing, you put 0. Then you go back here, you leave it as bottom only. Bottom only means single. Although this yes, this is for, just understand that bottom only means single, top and bottom is double. So since the column base has double reinforcement actually, but we are taking it one by one because they have different size of reinforcement. So we are using single and in 2 times. So the next thing you're going to do is you change the length bar diameter to 12. The breadth bar diameter, you also change it to 12. Then after that, you check on the spacing is the same, the spacing is the same, then you click add. So in this case, in the second row, we are only interested in the reinforcement here. So if you go further, you can see most of what we have are 0, 0, 0, but the reinforcement now, you see the reinforcement, they will have the same length. You see the first row and second row. First row represents Y16. So when I click first row, it returns Y16. Second row is for Y12. They have the same length, but the kg differs because Y16 is heavier than Y12. You see, the first row, which is for Y16, the kg is this. That's for the length bar. The for Y12, the kg is this. So if you scroll further, let's go to the total reinforcement. Total reinforcement, they have the same length, but they have different weights. So that's how to do to work with column-based form. And if you have, let's say you have BT1, base type 1, base type 2, base type 3, base type 4, and you want to do all of them here, you can change the description again to base type 1. Let's say base type 1 is just 1.5 by 1.2 meters, and the number is let's say it's 25 numbers. And the even if they have different excavation depths, you can also do that here. Let's say base type 1 is 1.2 meters, it's not 1.5 meters, and the footing is let's say 0.3 meters. Then let's say base type 1 has Y12 at the top, Y12 at the bottom. So we can change this to top and bottom, and we just change the diameter to Y12 at the top. Sorry, the length side Y12, the breadth side Y12. They have length bar spacing 0.2, breadth bar spacing 0.2. Then you click add. So this gives you for base type 1, gives you the excavation, leveling and compacting, anti-termite, earthwork support, and other data. If you scroll to the end, the total reinforcement is 990 kg because it is top and bottom, Y12 at the top, Y12 at the bottom. So I'm supposed to put Y12 so that we know that it's Y12. So I'm going to delete the first one I did by clicking this row, then click remove, then I'll change this to Y12, base type 1, Y12, TB. That's Y12 top and bottom. Then I click add. So then let's say we have base type 3. Base type 3, let's say base type 3 is just Y16, or let's say it's just Y12 bottom only. I'm going to abbreviate. BTM is bottom, bottom only. So let's say base type 3 is 1.8 by 1.5 meters. Then let's say base type 3 is just 4 numbers, and the excavation is the same, the blending is the same, the footing is the same. It's also Y12 and others, you just click. So when you are done, you click export to Excel. So, but before you click export to Excel, let's create another folder where we are going to save all this data for today's project in. So we create another folder in the main folder. Let's give it day 4. Day 4 data. So inside this, okay, in this case now, we are going to create a folder for each of the projects or each of the form. You can create a folder for each of the form, or you can save all the forms into this particular day 4 data page. So when you click export to Excel, you click desktop, then you click EQS2 project, then you click day 4 data. Then the file name is going to be column basis because that's the name of the page. Can give it column base. Yeah, just column basis is okay.
It goes and it's better the formula. Hello, Salisu. Can you hear me? Stanley has gone off the radar. Hello. Sorry for the break in transmission, technical issues.
It's coming up right away.
Thank you.
Sorry for the break in transmission. Uh, I was at the stage of saving the the data for the column base, and the reason of saving is to show you how you can add up each of the quantities. You can add up all the quantities in excavation, concrete, formwork, and others. So when you open it in Excel, so you see it gives you the data page. So you can add up each of the this for excavation, this for so this for volume of excavation, leveling and compacting, and termite. So you can add up the data from here. So the for the reinforcement now, yeah, that's one of the importance of using an appropriate description. You can see here we use Y16. So in the when you get to total reinforcement, you should be careful. We have breadth bar in column base, length bar. So if you are interested in the total, if you have the same type of reinforcement in the length side and the breadth side, you can get the total from here. So here the first row is Y16. So you should take note of that. Then the second row is Y12. So you can decide to sum up all the Y12 as row one, row, the third row, fourth row, and fifth row. They are all Y12. So you can navigate to the total reinforcement in kg. Since you know that from row 3 to row 5 they are all Y12, you can just drag to sum. Then you record this, you can write it on a sheet of paper. The total is at the base here 1270.4. Then you know that the first reinforcement is Y16. Then you record that. This is the last column that gives the values for results. The other ones, the other columns here are the imputed value, like the value for the length of base type 1, the breadth, the number, and others. And if you also want to make a correction, you can import back this page into the software and make a correction. So to do that is you need to close the page first. It's also another reason why it's important to save is if you should click on any other form on the right side, you go back to this column base again, the page will be empty. For example, if I should click ceiling and go back to column base, you see it's empty. Or let's say you close the software and just open it afresh, it's going to show you a blank page. But you can import the data that you've saved earlier on by clicking import saved data. So it can take you to anywhere on your computer, but if you check that and you see that you are on the right file path, you just navigate to the appropriate folder and select the appropriate file. It will bring back all the data that you saved earlier on. It's running all the data back to the application. Okay, now it has returned all the data into the application. So if you want to make correction on, let's say, the first row, you click on it. Immediately you click on it, it will populate the input cells with the input boxes with the data that yielded all these results. So you can make any correction, but before you make correction, you need to remove this one first. Let's assume we want to change the number of work to be 4. So you remove this one, then you change this to 4. Then you click add. Then this now comes to the bottom of, initially it was number 1, but since we removed it, it's now number 4. And if you want to make correction on another one, let's say you want to make correction on this third item, you just click it, then you remove first, you make correction. Let's say we want to change the number to 22, and then let's say you want to change the column base thickness to 0.4. Then after that, you click add. Then when you are done, you can decide to export again. You can save as a new file, or you can replace this. If you are saving as a new file, let's say I'm saving it as column base corrected. So yeah, we are saving it as a new file. But if you wish to replace the old one, you just click on that file, then click save, then it will ask you, do you want to replace? You click yes. So we are done for this item of work, column base. The next we'll go to is bulk excavation. So we have bulk excavation here. It's similar. The first is description. So in this case, we are going to assume values here. Let's say we are doing a bulk excavation for a 3 meters. Okay, let's say for a 5 meters by 3.5 meters depth work. 5 meters by 3.5. So the length is 5 meters, the breadth is 3.5, and the depth is, let's say, 2.1 meters. So here you say, let's say, basement excavation. The length is 5 meters, the breadth is 3.5 meters, the number of work is 1, the depth is 2.1 meters. Then this is a reinforcement at the base. If you are not using using fabric mesh, let's assume they are using a Y12 to cast on the base. So this also calculates the reinforcement and excavation, that's earthworks, concrete work, form work, and reinforcement will be calculated in the result section. So let's say we are using Y12 as the reinforcement diameter, and the bend, let's say it's just 0.1 bend. The spacing on the length side, let's say we are using 0.15 on the length side and 0.15 on the breadth side. Then the concrete cover 0.025. The base thickness, let's say 0.23 base. Then the blinding 0.05 blinding. Once you do this, you click add. So here the first column is description, the second is excavation, volume, leveling and compacting, anti-termite, earthwork support, blinding volume, base concrete volume, formwork to the edges, and then in this case, the formwork to the edges is in square meter because it takes the length, the perimeter times the thickness of the base, which is 0.23. Then the next is the reinforcement in the base in meters and in kg and also in tons. Then these values here, they are the imputed values. So let's say you have another work that is, let's say it's 12 meters by, let's say 8 meters. The length is 12 meters. So you are changing this to excavation 2, basement excavation 2. Let's say this is also 1. Let's say this one, the depth is 3 meters depth. And let's say the reinforcement on the base here is Y. Okay, let's say it's also Y12. But if it's different, you can change it. You click add. You see the first row is for the first one. Second row is for the second one. When I click the second row, the length and the breadth change. When I click the first row, the length and the breadth change. So this is the result for the second row. Gives you the excavation, the level and compacting, and all that. So you can keep on adding by changing the input data, then you click add. So it allows you to add as many as you want. So the next, on the right side, we have the reinforcement option 2. If the reinforcement is not just in math format, that you just have, let's say the type of reinforcement they use when you are casting top of let's say septic tank or sockaway, you know, that reinforcement arrangement just allows you to put horizontal and vertical bars. That's the type of reinforcement that the software assumes here. But if the reinforcement arrangement is different, this form at the right side allows you to pick each of the reinforcement from the drawing. Let's say you want to work on Y12. You pick on the reinforcement length. Let's say Y12 01. Let's say the first one is 10 meters and Y12 is the bar diameter. The number of bar, let's say it's 4 Y12. Number of work is 1. You click. So let's say you now have Y12 02. This is the grid line description. Let's say Y12 02 is 18 meters and the number thereof is 9. You click. So let's say you also have Y12 03. So let's say the length is 17 meters. The number thereof is 4. So this allows you to keep on adding. So as you are clicking it, it's giving you this is the reinforcement length for Y12 01, reinforcement length for Y12 02 and 03. What it does is for the length, yeah, it just multiply the length of bar including bend times the number of bar times the number of work. That's what you have here. Then it converts it to kg using the bar diameter that you have provided. Then also in tons. Then these are the imputed values. So if you want to get the total weight of reinforcement, now you can export this to Excel. You can give this basement reinforcement option 2. You can give it any name you like that would be easy for you to identify. it's still saving. So you see, it has finished saving. That's why it came up now. So now you can go to you can sum up all this to get the total weight in kg, which is 240 kg. So that's how you work on, you use this reinforcement option 2. The next we'll be looking at is columns. If you're interested in just columns, you can use this form. This form has two parts. The regular column and the round column are at the bottom side. So you can choose this, whether the column is attached or isolated. So let's say it's isolated. If it's isolated, you don't need the portion that is attached. So let's say column 1 is 0.23 by 0.23. Then the column bar length. So let's say the column bar is 3.7 meters. The reinforcement, let's say, is 4y16. So we put the number of bars as 4. Number of column 1, let's say, is 22 numbers. The stirrup length, you can use this stirrup calculator here, or there's another stirrup calculator on the right side of this page. So let's say you're using this one, 0.23 by 0.23, concrete cover 0.025. The laps, let's say you're using 0.2 as laps. So you click, you see the results here as 0.92. So if you're using 0.15 as laps, you see the result has changed to 0.87. So this is the result here. So we change this to 0.87. Then the spacing, provide the spacing here. The stirrup diameter, let's say it's y10. The column height, let's say it's 3 meters. You know, the column bar can be different from the column height. The column can just terminate at the floor level, then the reinforcement can extend to another floor. Then if it has tiling, that is that's tile finishing to that column, you provide the height of the tile. But if there is no tiling, you just leave it. Concrete cover 0.025. So if you don't have round column, you leave out the round column section. You just click add. So when you click add, if it shows you this thing, the reason why it's showing you this prompt form is because there is no value provided in all the cells here. So if you come across this, you just click continue. So when you click continue, the result.
Stanley, they are saying you should slow down. No.
Okay.
Thank you.
Okay, sorry for.
Maybe you might need to take that again.
Okay, let me take this again. We started with by clicking the form, which is column, concrete columns. You know, we have steel column and concrete column. We even have timber columns. So here we are working on concrete columns. And remember I said we are working on a case, a scenario that we are only interested in a particular item of work. We use this third item, building takeoff, previous training days, because we are interested in more than one item. We are interested in column base, trench, column in foundation, beam in foundation, and others. So this third item allows you to take off for a good number of items in a project. But if you're just interested in just a particular item, like we did for only bulk excavation, we did for only column base, now we are doing for only concrete column. That's where we use this form. And I said that the form has similar interfaces. It has input cells and the result form, which is at the bottom. Each input, the input cells or input boxes has allows you to type in numbers, and it has title at the top or at the side. And the title also has this unit The unit tells you the unit of measurement you are going to provide there. The columns on the drawing can be 230 by 230. So we are just making assumption here that we are working on a project that has column 1 and column 2. Column 1 is 22 numbers, column 2 is 15 numbers. So here, you just read each of the input cell. You read on the title of each of the cell, and you be cautious of the unit, then it guides you on the appropriate value to provide there. So we started with description, we put column 1, then we assume that it's attached. Sorry, it's isolated. Isolated means the formwork will be provided on the 4 sides of the column. Then next, we provided the column length, which is 0.23 because the unit is meters. We also provided the column breadth, which is also in meters. The reinforcement length, we assume we are using 3.7 because the column height itself is 3 meters. So let's say it projects 0.7 meters above the floor level. Here we are assuming a column at the superstructural level. The column, let's say the column height itself is 3 meters. So this 3 meters is what the software will use for concrete and formwork. But for reinforcement can be longer than the member itself. So that's why we're using 3.7 meters. We are just making assumptions here. You use what is appropriate for the project you are working on. The next is the bar diameter, which is 4y16. So we provided the diameter here, then the number is also provided here as 4. Then the next is the number of columns. We say we are assuming 22 columns for Y12. Then we use the Startup calculator. You can use this one on the toolbar at the top, or you can use the one at the right side. We have explained the Startup calculator day 1, day 2, day 3, so you know how to use it. Then we used it to get this Startup length. We are calculating just for one Startup length. The software we multiply by the total number of Startup to give you the total length of Startup. Then the spacing of the Startup, the diameter of the Startup, the height of the column, the concrete cover. How it calculates the Startup is it deducts concrete cover from this column height. Then the remaining value divided by this spacing plus 1, then multiply by the Startup length that you provided here. So after that, we click add. So when we click add, I said it will bring out this form in this case, because we did not fill in data for all the input boxes. The one below is for round column. We don't have round column here. That's why we left it blank. So you have to click continue to continue with the processing. So after we click continue, we have the results. I clicked it twice. That's why we have 2 results here. The result is given thereof. Concrete in column, the volume is given. Let me delete one of them. So concrete in column is 3.49. Formwork to sides of column, 60.7 square meters. The column reinforcement, you can also see that even the column is abbreviated in the results. The reinforcement is also abbreviated. We use terms that will be easy to understand by quantity surveyors. So the column reinforcement in meters is given. Column reinforcement in kg is given. Column reinforcement in tons is given. The column Startup, for that first case, we did not provide a value for spacing. That's why it's not given there. Then if you have another column, let's say you have column 2. Let's say column 2 is 0.45 by 0.23. Then let's say they have the same length, the same other data. Then you click, you just click add. You go through it. Okay, the number of column 2 is we are assuming 15 numbers, and the number of bars in this case is 6 numbers. So the startup length will change. So you can use this startup calculator from this pop-up or on the toolbar at the top. You select. We are using regular shape startup. Now the length is 0.45. The length is 0.23. The concrete cover is this 0.025. Then the lapse, we can use 0.2 as the lapse, then click calculate. So you have 1.36 as that. So you say 1.36, then you click add. So if it shows you this, you click continue. And if you are working on this page, you can also open another page to continue. If you want to open another page, you can minimize the software. So when you minimize, you go to your desktop, and this is my desktop. Okay, let me open the desktop from okay, on the desktop now, you can open another page. So you can have more than one session running. So if you hover your cursor at the icon at the bottom, you have 2 pages open. You can open more than 2 pages. So this one is for the column. So you can decide to open another one and continue work. Because as this one is running, if I should click any page here, it's going to replace what we have here. But before we continue, we'll click save. So this is column, concrete column. So we are still saving on day 4 data page or folder, day 4 data folder. So let's say I want to continue on the new version I just or new page I just opened. So let's say we want to continue with concrete wall. For concrete wall, it allows you to calculate or do takeoff for concrete formwork and reinforcement in concrete walls. Let me open a drawing.
Sorry, Stanley. Somebody is asking if you can experiment with attached column and beam.
Okay. Okay, let me do for the attached. The only difference is just the formwork. Let's say we have column 3, for example. Let's say column 3 is attached. So you provide the surface that is attached, which is, let's say, 0.23. Then the column length is 0.23. The breadth is also 0.23. Then the bar length, we use 3.7. The bar diameter, 16. The number of bars, 4. Number of columns, 20. Let's say this is just 12 numbers. Startup, 0.87. Startup spacing, 0.2. Startup diameter, 10. Then the height. Let's say the height is column height is 3 meters. We don't have tiling. The concrete cover is this. So if you don't want the software to be showing that form that we say whether to prompt you to continue, you can just provide values here, but you will not provide number of columns for round column. You just provide value in the length the just put 1 values here. But when you get to number of columns, you leave it as 1. Like the startup, you put 1, you put 1, you put 1, you put 1. The number, because it will multiply everything by 0 and it will still go back to 0. So you should not be scared that you get values here. So when you click click add, you see it did not show us that form in this case. And here we have for attached. You see the form work here is 16.560 because we provided a value for the attachment. So what it does is in calculating the form work, it just calculates the form work for only 2 sides. Or it just takes this portion, the portion that is attached to a particular surface. It multiplies this width by the height of the column, then times 2, because 2 surfaces are attached. Then that area is deducted from the total form work area. You see, I experimented now with a second scenario. I changed this from attached to isolated. Then I click add. You see the form work in this case is higher. The form work in case 2 is isolated, while the form work in case 1 is attached. Because case 2, we assume that the form work is on the 4 corners of the column, while case 1, the form work is just on 2 sides of the column. And what it does is, like I said earlier, it is this portion that it's deducted from the this portion times 2, because it assumes that the 2 faces are attached to wall. So it takes this 0.23 times 2, then times the height which you provided here, then it deducts from the entire form work area. I hope this answers the question. So you do the same thing for beam. For beam, we don't have provision for attached or isolated beam here. But when you are working on this particular form, it's there's provision for it. That's in the building takeoff and BOQ. So we move to concrete wall. So for concrete wall, we are going to use this drawing. This is a lift shaft, concrete wall. So here we need some data, which when you click concrete wall, it allows you to select whether it's attached or isolated. Then the next is you need to provide the length of the wall, the height of the wall, the thickness of the wall, the number. Or you can provide the area. If the wall, if you don't want to measure the length and the height, because some wall may be, let's say, trapezoidal in shape. So in that case, if you don't want to use the average height, you can just decide to measure the area and provide the thickness. So where you see or, it gives you another option. But for this case, we have the wall here. So for the length of the wall now, the in-to-in dimension is 1.65. So we say 1.65. So now we are going to compute the total length. 1.65.
Sorry, Stanley. Yeah, before we go far, so what if they attach the columns are 3 or 4 sides? If there are 3 or 4 sides to it, then someone wants to know why the result is not giving us startup details.
Okay, I explained that recently. The startup details did not show in the first case because we did not provide we did not fill in value for all the cells. So that's why it brought that error message out. I'm going to do another one now, and you will see that it will show you the stirrup details. Then for the question that if the formwork is attached on 3 sides, then you are going to add the total, the 3 portions. Let's say, for example, if I want to draw a sketch to further explain that. Let's say we have column like this. So let's say this is the column, and you now have the attachments. The attachment, it's attached on this side. Then it's also attached on this side. Then it's attached on this side. So what you will do is, this column is 230 by 230. You add 230 plus 230 plus 230. That's 690. Then you divide 690 by 3. Sorry, by 2. Say 230 times 3. That's 690. Then divided by 2. That's 0.345. So it is 0.345 you are going to put here as the attached portion width, because the software will multiply this value by 2, then multiply by the height of the column. Then it will now deduct that from the total formwork area. Originally, it will measure formwork for the 4 sides. Then after it measures formwork for the 4 side, it will now compute this area that you have provided to be deducted. It will multiply this value by this value, which is the height, then by 2. Then it will deduct the total area from the attached portion area. It will now give you a, okay, let's experiment it. Let's say we have column 4 in this case. Then let's say it is attached. Then the length is 0.23 by 0.23. The bar length is 0.7. The diameter is Y16. The number of bars is 4. Number of columns, let's say 22. Stirrup length 0.87. I'm going to show you why the stirrup did not show in the first case. So 0.2, the stirrup spacing, stirrup diameter Y10. The column height, we are using 3 meters. Okay, let's say there is tie 3 meters. Then 0.025. If you don't have tie, you can put 0 there. Then you need to provide value in all the cells here. That's why it did not give us a stirrup length in the first case. So you put 1 here as the column diameter, 1 column bar. You just provide value in all the cells except the number of columns. Number of columns, you leave it at 0, because when the software calculates all the values for concrete formwork and reinforcement in round column, we don't have round column, it will multiply all the value by 0 and it will still go back to 0. But if you don't provide any value, if you leave it blank, it will be giving you some error like we had in the first case. So number of bar, you put 1, you put 1 there. You just provide value in everything except the number of columns, because it's 0. So when it's add, you see we have formwork. So the formwork that it's calculating now is just for one side. It's just 0.23 times 3 times 22. You see, 15.18. Because originally it's supposed to calculate the formwork for the 4th side, but we have provided that it is attached. This portion is attached and this portion which provided is multiplied by 2. So back here, now the software has deducted this portion because the total portion is 0.69, then half of it is 0.345 times 2, it will also go back to 0.69. So it's just this portion that the form work has measured for in terms of form work. So that's why we have 15.18 as in the form work area. Then if you move further, you see now we have stirrup, and the stirrup is takes the stirrup length, which is 0.87. Then the number of stirrup is you deduct concrete cover from this because you don't have stirrup in the entire span. So when you deduct concrete cover divided by the spacing plus 1, then multiply by this, multiply by number of columns. That's how we got this. But in the case that I should change this now, the column height here, I change it to 0. I change all these values here to 0, 0, 0, 0, 0. So this is where we have that issue. If you click continue, you see in the second case, the stirrup is not showing. It's because I did not provide all the data. So any other question, or we can continue?
I think we can. Well, somebody was asking, okay, why do we have to divide the column with total by 2? Why do we have to divide the column width by 2? Won't this cause issues if someone forgets?
No. I'm not saying you should divide by 2. The reason why we divided that by 2 is because somebody asked that, what about if the formwork is attached in 3 sides? So if it is attached in 3 sides, that's why I said you sum up the 3 sides divided by 2. But if it is attached on only 2 sides, let me give another scenario. Let's say we have column here, and this column is only attached on this side, the left side, and the right side. If you have this case, you don't need to divide by 2. You just provide this 0.23 as the attached portion width. Let me do another one. You change this to 0.23. So in this second case now, let's say this is column 5. You don't need to divide by 2 again. In this case, you just provide that 0.23. What I'm saying is when you provide this 0.23, it will multiply that 0.23 by 2, because any value you provide here, it assumes that it's that same portion is attached on the opposite side. So when you provide 0.23, it multiplies this value by 2, then multiply by the height of the column. Then it deducts that portion from the entire column width. For example, now, if I click add here, column 5 now, you see we have the formwork to be 30.36. That's because I provided 0.23 as the attached portion. So it multiplies this attached portion by 2 originally. So the reason why we have to divide by 2 here is because we want the software to calculate for 3 sides, and it is programmed to calculate for 2 sides. So that's why on first I said you need to understand how it works so that you know how to use it. So in making it to calculate for 3 sides, you take the length here, the length here, the length here, then you divide that value by 2. So you provide just value for only this side, which I'm shading now. So when you provide the width of this side, it is programmed to measure for the opposite side also. So this is the opposite side. So it's going to measure for this side as well. But in this case, you don't need to divide by 2. When you provide for this side, it will multiply by 2 and measure for this side as well. I hope that answers the question.
Yes, let's go on. We take other questions later.
So we're at concrete wall. So concrete wall, we need to measure the entire length. So the entire length of this is the plan. This shows us the thickness of the wall, 230 mm. Then the reinforcement is Y12 and is double reinforcement in the wall. So what we need to do now is to measure the length of the wall. And it has an opening here. So let me quickly measure the length of the wall. We can use calculator to just sum up let's say this is 1.65, then plus 230, that's 0.46, then times 2. That's for the left and the right side. Then this one now, we are not going to take it out to out again. We just take it in to in. So here we have 1.65. Then plus 1.65 at this side. So we have a total of 7.52 meters as the length. So the description, you say concrete wall. Then you choose whether it's attached or isolated. Then the total length is 7.52. Then the height, let's say the height is 3 meters. The wall thickness is 0.23. The number of walk is 1. So if you provide values here, you don't need to provide values here again. I said where you have area, it says or area. Maybe if the shape of the wall is not just square or rectangular, if it's a trapezoidal or circular or some other shapes that you cannot easily ascertain the length and height, you provide the area, the thickness of that area, the average height, and the number. Then opening. We have opening in this case. If you check the plan, we have opening here. So the opening is 0.9 meters. The length also means the width of the opening, 0.9. Then the height of the opening is 2.1 because it's a doorway. You also provide the thickness, 0.23. Then the number is 1. So when you provide all this, you hit add. So here it gives you the concrete, wall concrete. So what it does is it multiplies the length, height, times thickness, times number. Then it will now deduct the opening. The volume of concrete in the opening will be deducted. So you now have an effective wall concrete. Same for the formwork, and it calculates formwork to the 2 faces of the wall. You know, the wall has 2 faces, so it calculates formwork for the 2 faces. It also deducts the formwork for the opening, then formwork to the edges. If you have another wall, let's say you have wall 2, you can change the length. Let's say the length is 9 meters by 3 meters. It also has an opening. Even if the opening is 2, you can change it to 2. So that's how you use this form. Then the reinforcement form at the right side of the screen allows you to measure the reinforcement. We have, let me delete this. We have Y12 reinforcement here. So you say concrete wall Y12. So here you choose whether it's single or double. In this case, the reinforcement is double, so we use double reinforcement. So the next is the height. The vertical wall height, we are using 3 meters. The horizontal length, we are using 7 points. Okay, in this case, the length is 7.52. 7.52. Then the next is the vertical bar length, including bend. So let's say it's 3 meters. Or if it has bend, you can, let's make it 3.2 to cover up for bend. The bend can be more than 0.2. Just put what is appropriate. Then the next is the horizontal bend. If you check the drawing, this is the bend I'm talking about. This is the bend. So this bend now, let's assume is 0.1, 0.1 on this end, 0.1, 0.1. So if you add let's say we are allowing 0.4 for the bend. So if you add 0.4 to this, you have 7.92. Then the vertical bar diameter is 12. Horizontal bar diameter is Y12. You see the unit of measurement is on the right side in millimeters. Then the spacing, if you check the spacing is not given here, but or we can assume 0.15 meters spacing on the vertical reinforcement and horizontal bar. Where you see bar, it means reinforcement. It's also 0.15 spacing. Concrete cover is also 0.025. Then the number thereof is 1. So when you click add, it gives you the reinforcement in meters. So the total reinforcement in meters is 325.12 in kg. This is for the vertical reinforcement in meters. Then the horizontal reinforcement in meters. Then now we now have the total reinforcement in meters, in kg, and also in tons. So from here, we move to another item. You can save. I didn't save earlier on, so let me save what we did. Concrete wall. So you hit export to Excel to save for the reinforcement. So as it's saving, I'm going to open another form. So we are going to work on drainage and covert. This is the type of drainage and covert. So we'll make assumptions here. It's just a simple box drainage. So this drainage, the software will calculate the earthworks, concrete work, and reinforcement. Earthwork in terms of the excavation, leveling and compacting, and others. Then the concrete work, it will measure the blinding, the concrete in the base of the drainage, concrete in the opposite walls, and also in the reinforcement, it will measure the reinforcement in the drainage as we have here. This is the reinforcement. Then this is where when it will give us the concrete and other details. So the information we need here, we need the total length of the drainage. We also need the depth of the drainage. We need the thickness of the two walls. We need the blinding thickness. We need the base thickness. We need some other data like the spacing of the reinforcement and others. We'll do it together. The drainage form allows you to choose the type of drainage. It's similar to the first form we worked on, which is the building takeoff form. This page has this form has different pages, and the page are accessed via these tabs. The first page is the regular shaped drain. Regular shaped drain is what we have here. The second tab is ring, in a case that the drainage is ring. Although most ring drainage are precast, which they bring and install on site, but maybe you want to cast your own on site, which is in situ. You can use this form to work on taking off. Then if it is trapezoidal drain, you use this tab. Then this allows you for measurement of apron wall, which is a regular shaped apron wall, trapezoidal shaped apron wall, and the apron slab. Then the next is the beam. And this is what we mean by the apron wall is we don't have it in this drainage. We have it in some other drain that has apron wall. After where you have discharge, you can have apron wall there. So we start with regular shaped drain. In this case, you need to make some settings before you start. The first is the formwork. You need to choose whether the formwork is just for single phase or if it is double. Single phase is when the concrete is cast against the excavated surface. In that case, you just provide formwork in one side, but double phase is where the formwork is the formwork is provided on two faces and the concrete is poured into it. So let's assume double phase. The next is you need to choose the bar arrangement for the drainage slab, whether it's bottom only or top and bottom. And according to what we have here, it is bottom only. Then the next is the side wall, the reinforcement, whether it's single or double. So we are using single here. The next is the bar arrangement for drainage cover. It also allows you to measure for drainage cover at entrances. You know, drainage also have a cover at the entrances. So the reinforcement, you can choose bottom only here also. So after you have done that, you proceed to the first, which is the drainage length. Provide drainage length, we are assuming 200 meters as the drainage length. So if the drainage is on the left and on the right side of the road, you can decide to just sum up all the length, or you can just provide for the right side. Then at the end, you will now provide the number that it is two drainages on the left and on the right. Then you provide the excavation width. The excavation width can be different from the drainage width itself. As you can see on this form here, the drainage is within the excavated portion. So the excavation width is, let's say 1.8 meters. Then the drainage width, let's say it's 1.2 meters. So the next is the excavation depth. And you should also note that the drainage excavation depth and the drainage wall height, they may not be the same. Because of the surface of the road can be filled up to a particular level. So the drainage wall can be higher than the drainage excavation depth. So let's take 0.8 as the, okay, let's say 0.5 as the drainage excavation depth. Then the drainage wall height, let's say 0.8 meters. Then the next is blinding. Blinding, let's say 0.05 for blinding. Then the next is drainage base thickness, let's say 0.15. Then the next is drainage wall thickness, let's say 0.15 also. You can decide to use 0.1 if you wish. Okay, let's use 0.1. Then the drainage cover, that's the concrete slab that they cast at maybe entrances. The length and the breadth of the cover. Let's say the cover is 1.5, or let's say the cover is 2 meters by 1.2 meters. The breadth has to be, can be the same as the width of the drainage itself. The next is the thickness of the cover. Let's say the cover thickness is also 0.15. Concrete cover is 0.025. Then the next is you provide the drainage slab length bar length. The meaning of this is the drainage has length and width. The entire length is the 200 meters. So since we have the length of the drainage as 200 meters, the reinforcement will be more than 200 meters because they are going to have laps at some intervals. Since the length is very long, you can increase that 200 meters by a value to cover up for laps. So we use this value modifier to do that. So we use the value modifier, you just click on this icon that has 2 arrows, one pointing up, one pointing down. Up means to increase, down is to reduce. So we are increasing the length 200 by, let's say 15% to make up for laps. So now we have 230 as the length of the reinforcement on the length side. Then the drainage slab width bar. This means that on the width is at the base. The length of the reinforcement at the base. The drainage is 1.2 meters wide. That's the drainage itself, but the excavation is 1.8. So we are taking this 1.2 meters as the width bar length. So we can also add bend on 2 sides. So if you add, if the reinforcement is not U-shaped, that means you need to add bend.
Hello, Stanley.
Ma.
We have like 10 minutes more.
Okay.
We can quickly round up.
Okay, let's quickly round up. Just the most important thing is to read the title on each of the cell and understand what is there. Then you input the appropriate value. You get your result. So let me just quickly round up this. The drainage slab, let's say we add the bend on 2 sides, we have 1.4. Then the slab spacing, let's say it's 1.5. The breast size spacing is also 1.5. Then the drainage wall horizontal bar length is also 230. It's the same with that. Then the vertical is 0.8. Then the spacing is also 1.5, 1.5. Then the drainage covered, we are using 2 meters by 1.5 by 1.2 meters. So let's assume the slab, the entrance slab has the same reinforcement as the member itself. Then the spacing is 0.15, 0.15. Then the reinforcement diameter, let's assume we are using Y12 all through. Y12 at the slab, Y12 at the wall, and Y12 at the entrance slab. Then the number of walls is 2 walls, because we have wall at the left, wall at the right. Then the number of drainage cover, let's say there are 5 entrances. Then the number of drainage is 2. So remember, we have 2 drainage walls and 2 drainages, drainage at the left side and on the right side. So once you are done with this, it gives you earthwork That's excavated volume and others. So if you want to view it in a BOQ format, you click results. Then when you click results, just like we did the other days, then you click BOQ, you see it's arranged in a BOQ format. The next is BOQ. So when that is done, you can, we now have it in a BOQ format. So this is the quantities for excavation, removal of surplus material, backfilling, leveling and compacting, earthwork support, anti-termite. Then for concrete work, we have blinding. Then we don't have ring. That's why this is void. Then we have drainage slab concrete. So these are all the value. Concrete work is there, reinforcement is there, formwork is there. And thank you very much for your time.
Okay. I'm sure we are all good. I only have like 2 questions here, but I'll not be taking one. If you don't put your name and you're using anonymous, your question may not be attended to. But I'll take this one because I'm just giving the rules. If you want to ask any question, please let your name, let it appear so that we know that who we are answering. So they say you should please use the value modifier tool again. The person didn't get it. Then the second question is the reinforcement lapping that you said the percentage increase should be used for the 200 mm drainage length that you just showed. So is this a standard practice? What if we are giving the length for each lapping? Then somebody asked before I was logged out, the question is not showing that. If we were given the bending schedule, if you are given the bending schedule by the structural engineer, do we use it, or we still have to use the rule of thumb or use our own measurements? So I have 3 questions in value modifier that you should please use it again. Then the reinforcement lapping. Then if we are given the bending schedule by the structural engineer. Then
Okay.
you say you did not finish the explanation on the beam concrete. So if you can do that, answer all those ones in 5 minutes.
Let me quickly start with the first one, which is the value modifier. The value modifier is on the top 2 bar. This one that has 2 arrows. When you click it, this form comes up. You use this to modify any value, either increase or reduce. So if you want to reduce, you select reduce. You provide the value 200 or whatever value. Then the percentage you want to reduce it by, let's say by 15%, you click. If you are increasing, you change this to increase. Then you click calculate. That's how to use it. Then the second question, that if you have laps, that is provided, then you don't need to use the value modifier to measure to get your total reinforcement length. In that case, let's assume the lap is 600 mm. Then you divide the total length, which is 200. You divide the total length of the member by. I want to show you how to do it. I don't know why this thing is not showing. Okay, you say 200 divided by the length of one reinforcement, which is 12. So you have 16 instances, then times the laps, which is 0.6, then plus 200. So in this case, you have 210. So that's how you use it. If you want to, you provide the appropriate value here. Then where you are giving a bar bending schedule, then you don't need the reinforcement aspect, you can use the one that the structural engineer has given you. Then you just use the software for earthworks, concrete work, and form work. Then for the last question, the fourth one, which is the beam concrete. The beam concrete is this form. You click it, you provide the description, which are, let's say we have this case here. Let's say you have a beam like this. So that you take the total beam gut, or you want to do it beam 1, beam 2, beam 3, but you can take the whole beam gut and take it as your beam length. Then you just say beam. Let's say it's first floor. Then let's say the total beam length is 319 meters. Number of beams, 1. The beam width is 0.23. The beam depth is 0. Let's say you have 0.45 and 0.6 beam. So you can change the description to 450 mm depth. Then the bend of the reinforcement, you can provide a bend here. The main bar is 4. You use this if all the reinforcements have if it's Y12 or Y16 all through, that's when you use this. So let's say we have 6 of Y16. Then the stirrup, you use this for the stirrup. In this case, we have sorry, I mistakenly clicked something else. Let me quickly open another forms. Beam 450, 230 by 450. So you provide the total beam 319, number of beam, number of beam is 1. The beam is 0.23 by 0.45. Then the bend, you can say, let's say 0.2. The number of bars, let's say 6, 3 top, 3 bottom. Then the stirrup, 0.45 is the length, the breadth 0.23, the laps 0.2, concrete cover 0.025, we have 1.36. So you say 1.36. Then the spacing is, let's say you are using 0.2, put 0.2. The stirrup diameter, let's say it's Y10, concrete cover 0.025. Then the main bar is Y16. So let's say we don't have a secondary bar, we don't have the bar number there. So when you click this, it gives you the concrete volume, formwork. Yeah, it gives you formwork in case of attached, formwork in case of isolated. In case of attached, you calculate formwork on just the 2 sides, excluding the soffit. Isolated, calculate formwork to both sides and soffit. Then gives you the main bar in meter, in kg, and in tone. Secondary bar is not provided, and stirrup is provided. But in the case that you have a beam that has a different type of reinforcement, you use the reinforcement option 2 here to do it. Because of time, we cannot look at that. Maybe tomorrow or next week we'll look at a case where you have different types of reinforcements in the beam. Thank you.
Thank you very much, Stanley. I think we've done well in answering questions as the thing was going on, but it seemed that it slowed us down a bit. So maybe we won't go that route again. And just like I said, please, if you're asking any question, please put your name there. And I've said it over and over, maybe some people didn't start with us, that we're sorry the recording came late for last week, but we'll try and make sure that we get it for these 2 sessions and this weekend session, that we get it early. So I don't expect people to keep asking me the same question about it. I've said it, we'll always get the recording, but because it was the first time, that was why the last one came late. But I can assure you that the remaining will not be this late. So I want to thank everyone for their patience, even when there was technical issue, and even me, I was logged out like twice. I don't know if anybody noticed that. Then the page, the platform will be open this afternoon for like an hour or 2. So if there is any question that Stanley can attend to, please put it there. But please, like I always say, put informed question that all of us will learn from. If there is any other thing, please contact Stanley individually, privately. Contact him privately for any other thing. But if it's a question that everyone will learn from, please put it there so that we all learn together. Thank you so very much for your time. And I
Thank you.
hope that we've all learned 1 or 2 things extra. So we'll see you next weekend by God's grace, 10 a.m. on Friday. We'll try and put the recording earlier. Thank you so very much, and God bless. Have a great weekend.
Thank you. Thank you, ma'am. Bye.
You're welcome. Salisu, thank you so much. Thank you. So Salisu, can we get the recording early?
We'll get it on Monday.
Thank you. We
Monday
appreciate
morning.
that. Monday morning. God bless you. Thank you.